Okay guys, we're going to learn today about mean absolute deviation. And this is one of the ones that you haven't learned yet in 8th grade, and this is probably the only thing you haven't learned yet. So this video is going to be a little bit longer, but try to stay with me. If you can, get a piece of paper and work these problems out with me. Okay, so mean absolute deviation, or what we call MAD, we're just going to break down the words first. Mean is the average. You know that because you've probably done that several times in your other math classes. Deviation is how far apart it is from the average or from the norm. So we're going to try to figure out how far apart these numbers are from the norm or from the mean. So first we need to find the mean. So we're going to add them all up. And if you add up 0, 1, plus 2, plus 2, plus 2, plus 4, plus 7, plus 5, plus 7, boom, I said that wrong, plus 4, plus 4, plus 5, plus 7, you're going to get 27. So your total, and then we're going to divide the total by the numbers, how many numbers are in your set. And in this set, there are 9 numbers, okay? So when you divide 27 by 9, you should get 3. So we know our mean is 3. So if we made a number line, and we're just going to label them, let's go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 4, 5, 6, 7, 8, and 9. So we need to figure out where these are. So we know this, the 3, we'll do that right too. The 3 is our mean. Okay, so we need to know how far away these are. So first we have a 0, and then we have a 1, and then we have 3 2s. 1, 2, 3. We have 2 4s, 1, 2, 1, 5, and then 1, 7. Okay, we need to figure out how far they are away from our mean. Okay, so let's do this. We have 1 that is 1, 2, 3 places away, so we'll make it 3. We have 1 that is 1, 2 places away. We have 3 that are 1 place away. We have another 2 that are 1 place away. And then our 5 is 1, 2 places away. But the 7 out here is 1, 2, 3, 4 places away. Okay, so then when you figure out how many places away they are from the mean, or how far they deviate away from your average, then we're going to add them up and take the average of that. So you have 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so there's about 17 places, but then in order for us to find the mean again, we have to do that 17 divided by how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and you should have 9 on both, or whichever number is in your data set on both. So then we're going to do 17 divided by 9, and you should get about 2 and 1/10 repeating on that. Okay, so this is just quickly how to find the mean absolute deviation. Okay, you don't have to draw the number line every time, but we have to figure out how far away each one is. All right, so let's do the next problem. Okay, example 2 says find the mean, median, and MAD, which is the mean absolute deviation, of the number of runs allowed for each pitcher. Okay, all right, so let's do Tim's first. Okay, so he's a pitcher, and how many runs he allowed in for each game. So first, we're going to add them all up. We have zeros, and you have 2 and 4 is 6. That's going to be 10, 15, 20, 10, 15, 21, 27, and then that's going to be 35. So 35 total runs, but then for us to find the mean, we need to divide them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and there are 10 total in our set. So when you divide that, you should get 3 5/10. So his mean is 3 5/10. Okay, the median. Remember, the median is in the middle. So if we have 10, we're just going to go in. Okay, 1, 2, 3, 4, and then our 4s are right in the middle. Normally, if there were two different numbers, you just take the average of those. But since it's 4 and 4, our median is 4. Okay, and now we need to find the mean absolute deviation. How far away these are from your mean. So now I'm going to do it in table form. And I prefer the table form just because it's easier for me. Okay, we have a 0, 0, 0, 2, 4, 4, 5, 6, 6. Oh, let's make those a little bit smaller. Okay, and then we have our mean, which is 3 5/10 for all of them. And this is going to be the difference. Okay, but we're going to say the positive difference. Okay, which means we're going to take the absolute value of each one. Okay, so 0, to get from 0 to 3 5/10, you would go over 3 5/10. And you've got 3 of those. Okay, so how far away is 2 from 3 5/10? Well, if you're adding, you would go over 1 5/10. Okay, how far away is 4 from 3 5/10? And you can go 4 minus 3 5/10, and you should get just 5/10. And you've got 2 of those. And then how far away is 5? Well, we switch this to a 5. 5 minus 3 5/10 is going to be 1 5/10. We've only got 1 of those. You should see some sort of pattern here. So if you have 6 minus your 3 5/10 to see how far away that is, you should get 2 5/10. Okay, and again, 2 5/10. So then we have to have 8. 8 minus 3 5/10 should give you 4 5/10. Okay, and I did this kind of quick, and you can do this in your calculator, but you're going to have to do this each time, but make sure when you do it, like if we were subtracting 0 minus 3 5/10, you would get negative 3 5/10. But remember, we are taking the positive difference, which means we're going to do the absolute value. The absolute value means how far it is away from 0, and that is 3 5/10 away from 0. So now that you have your differences from your mean, we have to take the average again of these. So I'm going to add these up a little bit different just because you have halves, okay? So since I don't have a calculator, you have 3 5/10 together, that's 7. 3 5/10 and 1 5/10 is going to be 5. You've got 2, that's going to make 1. 1 5/10 and 2 5/10 is going to give you 4. And then your last two, 2 5/10 and 4 5/10 is going to give you 7. So then I'm going to add them up from here. Okay, you have, you have 11 here, and then you have 12, and then your 1. So you should have 24. And then we're going to divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The number of data in your data set. So then we're going to do our 24 divided by 10, which should give you 2 4/10. And this is your MAD, your mean absolute deviation. Okay, so that was a lot, but for the mean, you should already know how to do that. So let's put Tim's up here. And we'll put Tim, and his mean is 3 5/10. His median is 4. And his MAD, his mean absolute deviation, is going to be 2 4/10. Okay, but let's think about this. This 2 4/10, that's the average distance he is away from his mean. So if he's a pitcher and this is what he is pitching, or the runs that he's letting in, this is about the average it is from the mean. Because for each game, he's going to give about